Hello and welcome to homework 7.04, your last homework before the system of equations test. Alright, so this is our last chance to get ready. Alright, there will be multiple choice on that test. And when you get a multiple choice question, it's going to look something like this. If negative a plus 3b equals 13 and a plus b equals 5, the value of b is. So what can sometimes make these a little tricky is that they're only looking for one of the letters. So you don't want to accidentally solve for the wrong letter or circle the wrong choice. So my advice is do the whole problem, find both letters, and then go back and circle the one that they're actually looking for. Alright, so let's start this just by writing the problems the way we're used to seeing them. So we've got negative a plus 3b equals 13. And a plus b equals 5. So I've got them written one underneath another, just the way we've been seeing them all along in class. Okay, so next question is, how do I want to solve this? Do I want to use elimination or do I want to use substitution? Now, you might be thinking to yourself, substitution, because look, I've got these letters that I can get by themselves pretty easily. All I would have to do is subtract b, or I could subtract a, but there's an even easier way. This right here is a negative 1. This right here is a positive 1, which means we have opposites. So I can add these together. These will cancel out. I'll have 4b equals 18. Divide both sides by 4. And b equals 4.5. Okay, so there's one of the letters. If I want to know the other letter, I just plug it back into the other equation. So I've got a plus b equals 5. I could have also used negative a plus 3b equals 13, but this one's a little easier. Plug in the 4.5, so I get a plus 4.5 equals 5. Subtract 4.5 from both sides and get a equals 0.5. Okay, so I've got all my choices here, 1, 7, 4.5, and 4. It's asking me for b, the value of b. So it's not going to be this 0.5 here, it's going to be this 4.5, so choice 3. Okay. Number 2, solve the system of equations using elimination. All right, so we've got two equations here. Elimination means we need to make opposites. Right now, I don't have any opposites, so I'm going to have to create them. All right, so that means I'm going to end up multiplying both equations by some number. Now, the question is, which letter do we want to get rid of? I'm going to go with the D just so I can stay away from all these negatives here. So I'm going to try to eliminate the D. So the way I do that is I take this 8 that's down below and I bring it up top. I take this 6 that's up above and I bring it down below. Now 8 times 6 is going to give me 48. 6 times 8 is the same problem, so that's going to also give me 48. The problem is both of these are positive. So positive times a positive, positive times a positive. If I want something to cancel out, I need a negative. So what I'm going to do is I'm going to stick a negative in front of this 6. I could have also stuck it in front of the 8. It's your choice, but it's got to be in front of one of those two numbers. All right, now I'm going to do my distribution. 8 times negative 2 is negative 16c. 8 times 6 is 48d. And then we're doing another 8 times 6, so that's just another 48. Okay. Down below, I have negative 6 times a positive 7, so that's going to be a positive 42c. I have a negative 6 times a positive 8, so that's going to be a negative 48d. And then I have a negative 6 times a negative 5. Negative times a negative is positive, and I get just a 30 there. All right. I'm ready to add these together because I now have opposites. These will cancel out. Negative 16 plus 42 is going to be, let's see, 26 C. And then 48 plus 30 is going to be 78. So I'll divide both sides by 26, and I will get C equals 3. All right, so that's the first half of the problem. Now I have to solve for D. I pick one of these two. Doesn't really matter which one you pick. So I'm just going to go with the top one. Negative 2C plus 6D equals 6. All right, negative 2C plus 6D equals 6. I'm going to take this and I'm going to plug it in for C. So I get negative 2 times 3 plus 6D equals 6. Negative 6 plus 6D equals 6. Add 6 to both sides. 6D equals 12. Divide both sides by 6. D equals 2. Alright, so I've got both of my answers there. C equals 3, D equals 2. All that's left is to check to make sure that we actually got it right. So I'm just going to type these in. Negative 2, and then instead of C, I'm going to type in a 3. Plus 6 times 2. Hopefully that's going to give me a positive 6, and it does. And then again down below, negative 7 times 3 plus 8 times 2, and hopefully this is going to give me a negative 5. And it does. So that tells us that we did that one correctly. All right, let's take a look at the back. Solve the system of equations using substitution. All right, so here we're looking for a letter that's by itself. We were kind of nice on this one because we gave you a letter by itself. We didn't make you kind of find one on your own. So let's take this part right here, because that's what x is equal to, and then we're going to plug it down here wherever we see the x. So when we rewrite this bottom equation, it's going to be negative 7. And then instead of writing the x, we have 2y plus 11. And then we just keep going. Minus 2y equals negative 13. And now we have an equation that we need to solve. So we'll distribute that out. Negative 14y minus 77 minus 2y equals negative 13. Combine our like terms, so negative 16y minus 77 equals negative 13. Add 77 to both sides, and we get negative 16y equals 64. Divide both sides by negative 16. I'm going to write it over here. Y equals negative 4. Okay, so that's half of the problem. Now we have to go and plug it into one of these two. I would say the top one definitely looks easier for this one. So x equals 2y plus 11. This negative 4 goes in here. We get x equals 2 parentheses negative 4 plus 11. So x equals negative 8 plus 11, or just x equals 3. So if you thought about this as two lines, the lines would be intersecting at 3, negative 4. And again, we can check that. All right, if we check the top one, let me see, 2y, so 2 times negative 4 plus 11 should equal x. X is 3. So let's see, does it equal 3? It does. And then if we check the second one there, we've got negative 7 times 3 minus 2 times negative 4, and hopefully this is going to give us a negative 13. And it does, so we are good on number 3 here. 4. Solve the system of equations using substitution. All right, so this one we were not as nice, because you can see that none of the letters are by themselves. We have a y next to a 5x. We have a negative 3x next to a negative 2y. So we have to get one of the letters by itself. We always want to pick the easiest one, and the easiest one is going to be the one where we don't have to divide. So here we would have to divide by a 5. Here we'd have to divide by a 3. Here we'd have to divide by a 2. Here, because it's a 1, we don't actually have to divide by anything. So we're going to take this equation. We're going to add 5x to both sides. We're going to get y equals negative 7 plus 5x. And voila, I have a letter by itself, and I didn't have to do any division. So now I can take this, and I can plug it in for y down in our second equation. So when I rewrite that, it's going to be negative 3x minus 2, and then instead of the y, I'm plugging in the negative 7 plus 5x equals negative 12. All right, now it's just going through the algebra. So we're going to distribute. Negative times a negative is a positive. Negative times a positive is a negative. Okay, I'm going to combine like terms. Negative 3 minus 10 is negative 13x. Plus 14 equals negative 12. Subtract 14 from both sides. Negative 13x equals negative 26. Divide both sides by negative 13 and get x equals 2. Okay, so there's the first one. Now we still need to find y. Pick which one of those you want. Again, I'm going to use the top one just because I think there's less work involved there, since there's no number in front of the y. I'm going to take this 2 that I got, and I'm going to plug it in for x. So I get y minus 5 times 2 equals negative 7, or y minus 10 equals negative 7. Add 10 to both sides, and I get y equals positive 3. So again, if we actually were to graph these lines, they'd be intersecting at the point 2, 3. And just to prove that that is in fact the case, let's plug them in here. So the first one was 3 minus 5, minus 5 times 2, and that should give us negative 7. And it does. The next one was negative 3 times 2, because that's our x, minus 2 times 3, because that's our y, and this should give us negative 12. And it does, so it checks out, and we're good there. All right, let's read number 5. Determine the best algebraic method to solve each of the following system of equations. Explain your answer. You do not need to solve the system. All right, so we're just looking at these, and then we're picking which way would be the best way to solve it. So the first one here is going to be substitution. All right, so the question is, why is it going to be substitution? Well, we have letters by themselves. All right, this one is really suited to substitution because both letters are by themselves. We don't need to have both letters by themselves. Up here we only had one letter by itself, but this makes it even easier. We just would have to circle this 2x minus 1 and then plug it in down here. So that'd be an easy way to do this one. And the reason would be you can either say letters or variables that are by themselves. Right? So you have variables that are by themselves, which makes it easier to make the substitution. Over here, we have 2x plus 3y equals 9, 5x minus 3y equals 12. It's not really going to be easy to get a letter by itself. We have the x's and the y's all lined up, so this would be a good one for elimination. And this is especially good for elimination because we have a positive 3 and a negative 3, which means we already have our opposites, or the technical term would be the additive inverse. All right, so we can just write you already have opposites. Right? And that finishes up this homework. So I hope this was helpful, and I hope you're now ready for the test. Have a good day.